Oh, somebody already started it. All right, great. So welcome to the community meeting. As always, we have this occurring weekly. We have a small agenda for today. We will do some moves in the agenda, and I will let Niraj start with the pull request that we've been working on in the IBM Cloud configurations for IBM Cost Default Backend Store. So basically, just a heads up, like an overview on that, and I will let Niraj to speak more about it. As you may know, today we in the noobaa-operator side, we support multiple backend stores, default backend stores, which means that, for example, if noobaa gets deployed on top of AWS cluster, I mean the OCP and the OCS gets deployed on top of an AWS cluster, then noobaa's backend store, default backend store resource will be on top of S3, which is on top of AWS. So in Azure, obviously, we will use the blob storage as a default backend store. And what we have right now, the PR that we've pushed right now, is that when we will be deployed on top of IBM costs, we will have on top of IBM infrastructure, we will have the backend store as default on top of IBM costs. So Niraj, you are on the call. I will give you I mean, if you want, you can present, or we can just use my presentation. Please explain, like, basically briefly the changes and how to deploy this and how to use it. I think, or
Sure,
if you
sure.
want me, I can explain that, whatever is better for you.
Sure. So we can use same presentation, no issue. So the idea behind this PR is to enable the noobaa backing store to get configured to IBM Cores in IBM Cloud. So as you know, the IBM Cloud is hosting the OpenShift as well. So for that, we have the UI and CLI support as well, right? So at backend, we have the automation, which is handling the deployment of the OpenShift cluster and then installing the required services as well. So once the cluster creation is successful, the OCS is getting deployed on the cluster, right? So at the time of the OCS, the noobaa is also getting deployed along with the OCS, right? So currently, what is happening is that whenever we are deploying the noobaa or OCS in IBM Cloud, the backing store is getting configured to PV pool, which is basically the safe one. So this PR enables the configuration of the backing store to the IBM Core service. So for this purpose, what we have done is, like, when the OCS is getting deployed, at the same time, the course credentials are getting created under the target namespace. It could be a noobaa, or it could be a... So currently, it is the OpenShift storage namespace where the OCS and the noobaa is getting deployed. So the credentials will be getting created under that. So the reason for creating the credential is, like, currently IBM Cloud is not supported by credential operator. So, and still the plan is not decided, like whether we are going with the credential operator or the port identity. But currently both supports are not there. So now this PR, what it does, it looks for the course credential under the target namespace, wherever the OCS is getting deployed or wherever the OCS is deploying the noobaa. And it reads that credential and it tries to configure the IBM Cores backing store. And using that credential, it creates the bucket under the IBM Cores environment, and it used that bucket to configure as the backing store. So this is the brief description about this PR. And this PR also allows, like, if someone wants to deploy the standalone noobaa in a IBM Cloud environment, then it automatically detects whether the noobaa is getting or operator is running in the IBM cloud, so it will wait for the credential to get created under the target namespace. So it can be. It also supports the standalone deployment of the noobaa in the IBM cloud.
Yeah, that is basically it. I just need to add that there are obviously, like Niraj said, two flows. There is the flow which is the downstream flow and the upstream flow. So in the upstream, the person itself who uses and installs noobaa should create the secret by himself under the namespace of the noobaa where he deployed it. But in the downstream, the IBM operator that deploys the OCS and OCP on top of IBM will actually they have an automation that deploys everything and creates the secret under the OpenShift storage namespace. And we just basically list the secret. You can see it in the code. If I will go to the files that are committed, we basically use the IBM cost storage. We just list the secret, and we take the values from the secret, the endpoint that we want to target, and all of the regions and credentials, and just use it and create the backend stores on top of that. Yeah, so this is the feature. It is merged already into the master of the operator, and it is available on the master branch. There isn't a release right now for this, but you can obviously build a master branch and use it. And
Jenny, just to update, it will be backported to both the 4.7, the 5.7, and the 5.6 branches.
Yes, which is we have the backport, but we did not merge it yet, right, Nimrod?
Yeah, the 5.7 backport is up. I'm waiting for another fix, and I will merge both together. The 5.6 is not yet up, but it will be today. Yeah.
All right, great. So this is it. If somebody has any questions regarding this feature, just feel free to bring them up right now, or we will move to the next topic that we have in the agenda.
Evgeny?
Yes.
So that's great. So it's perfect for the backing store on the IBM Cloud. One requirement that I got for DLF, instead of having someone asked, instead of having the access key and the secret access key, maybe they could specify the IAM hash, so it would automatically generate that for them, right? This is IBM Cloud specific, so it's something to consider. Maybe instead of those two, someone could fill out their IAM credentials. Let me show a link somewhere.
Yeah, sure. You can attach the link to the chat, and I can open it.
Yeah, so basically this is the
let me open it. Share it.
Yeah, the alternative.
Yes. So yeah, so the service credentials, right?
Yeah, so it's instead of so they call it 8MAC, I guess. So you can go with. So this would generate the access key and the secret access key that we're used to, but also you can use instead the IAM token, right? So yeah, just as a thought, yeah.
Yeah, I agree. So, yeah. So so in IBM Course is supporting both HMAC as well the IAM keys. So currently we have support for the HMAC because that is straightforward. But yes, we can the future enhancement could be for IAM support as well.
Yeah, it is a simple change, right? We just need to push the IAM into the secret and read it as just like we read the access keys and the secret keys, right?
Yeah, correct. So along with that, we need to how the IAM key is working is slightly different way. So we can't use the IAM key directly. Before using the IAM key, we need to generate the access token, and we have to use the access token. So that code we need to inject somewhere.
All right.
Yeah,
Cool.
yeah, I think so.
I just updated it here, so we will have it recorded. Okay. Yeah, that's a good point, because obviously we did the first thing quickly in secrecy, and probably this is not the safest way to do that, and but it is. I mean, it is just the beginning, and that's the good addition to use the IAM keys.
Yeah. Of course. I just said it as an enhancement,
That's a
right?
good point.
Or as an alternative to people using the access keys. But yeah, I agree.
Yeah, that's a good addition. I agree. We should push it in the future as well. Any other comments regarding this PR? No. Okay. So we have Patrick right now on the call, and we wanted to discuss the func problems that we have, and with the MongoDB problems as well. I have this open, but I will open just in case to refresh if there are any changes there. So basically, I know that we already had this issue, Patrick, and it was discussed in the previous weeklies, right? We did some advances. Yeah, sorry.
Just wanted to say yeah.
Yeah. So we did some advances. We did some checks. I saw the history here with the tests that we did, and we came into conclusion that what I understood is that you've started using the same version of MongoDB as we are using right now, and not using a separate MongoDB version, which was you started. You had the issues with the MongoDB 4. something. Oh, I will just approve Quentin. Yeah, I will just admit Quentin.
Perfect timing.
Yeah. All right. Hi, Quentin. We were just starting in regards to the issue with the stats, with the func stats and the Mongo. So what I understood is that you were using an image of Mongo 4. something, right? It's hard a bit for me to find it here, but then you've switched to using the same Mongo that we are using in our deployment. And the issues went away, except the segmentation fault issues went away, except the slow down of the UI, right?
Nope. With the standard version, we still had the same issues. That's the output I posted just above. That's the seg fault with the standard version. And then when I tried the other version that guys suggested, the problems didn't arise, the seg faults. So 3.6.21 is the version that currently running and which is working.
Yeah, and it is a much more advanced version than what we are currently running on our master, right?
Yeah.
So I've confused the two, right? Yes. So the issues with the segmentation fault did not rise with this more advanced version. I know that we have some other things that we are working on right now with the aggregations and listings of MapReduce, and we have some. We've seen some segmentation problems there as well. I know that Nimrod and Hoad have been working, and Nimrod is on the call, and Hoad is not currently, sadly. But what we saw that we had some segmentation faults with map reducing for objects as well, so the issue is probably we saw that there are some Mongo issues regarding that, also always the resolvement was to just upgrade the Mongo version. So I will obviously cover this more in a bit, but I would like to move right now for the next problem that we are having, which is that you have lots of events, and you are saying that when you hit the barrier of 60K events, the MapReduce on the statistics for the functions slows down your whole system, right?
Yeah, when we hit this much of events, and then you try to refresh the UI, you can see the MongoDB pod going up to 2 cores, so reaching its limits, and then not being able to handle any other calls. And all you see in the log output is just MapReduce, MapReduce, MapReduce.
All right.
And correct me if I'm wrong, but S3 connections aren't possible at this moment anymore.
Yeah, because it isn't, the MongoDB can't handle any other calls. It's just stuck with doing MapReduce.
All right, I got you.
All services are not reachable.
Yes. So as far as I know from the code, I don't think that we have any indexes on the functions, on the stats, on the function stats. Let me just func stats. Let me just I can share my screen. And I will check live. I'm trying to switch here. Just a moment. I will present my screen. My visual code, right? Yeah. Okay. So if I go to func stats, I assume. So in indexes, we currently have only a single index of system ID and latency. And you are saying that the problem occurs whenever we are using the code in the func stat store, which is this one, which is the insert one. Just a moment.
Oh no, the insert one isn't the problematic code. This just works fine. We just commented this out. So if there aren't any stats produced, we won't have a problem with MapReduce jobs.
So the MapReduce didn't do any work, right? So you just disabled the pushing of the stats, but you did not comment the actual MapReduce, which tries to look for them, right?
Yeah. So yeah, because no events are written to the MongoDB, there won't be any MapReduce, so it's a non-problem. It's just a quick and dirty solution, which works quite nice for us at the moment. We really would prefer if we could have the statistics back, but for the moment, we prefer a stable NooBaa instance instead of an unstable NooBaa instance with some UI we don't need necessarily.
Yeah, I got you. Obviously, the priorities are for a working system instead of metrics. Yeah. So what I can see from the function, so this is the MapReduce probably that you are talking about, the query func stats. And you can see that it does a query on system func and time, and our index is on system ID and latency. So what happens is basically we are probably running MapReduce, which is unindexed. And obviously, if you have 60K records of MapReduce that tries to list them without any index, obviously, it will take more resources and more time to do so. So, in my opinion, what I would try in the first cycle is try to create an index for that and see how we will advance with an index. If we will have better performance and Mongo won't be doing much more heavy lifting, then I assume that could be a good fix for that. But if we will have more problems or the same problems with the index, then I think we will need to maybe discuss on and maybe deep dive more into this MapReduce. So in my opinion, this is like the easiest route to do, like just to add an index which is relevant for the query and see how it performs. So yeah.
Yeah, so if you can provide a merge request this week already, if it's just a simple one for you, I'm happy to test it out, or else we will probably test it in the middle of March, because I'm on a vacation starting next week till 11th of January. So if you have a quick fix this week, we can try it this week. If you need longer, it's no problem for us. So currently, everything is running fine. So it's just an added functionality we don't absolutely need.
All right, I got you.
Daniel, look at Guy's comment on the shell. Maybe if it's easier to provide just a Mongo shell command to set the index, so they can test it.
Yes, obviously, yeah. I think that's what I've meant to do, is just to provide a quick creation of index using the Mongo shell, and then test it quickly instead of like coding and stuff. And yeah, I think that after this meeting, I will send you the commands on Slack, Patrick, And if you have the running system, let's see, maybe we can advance quickly on that. If it will help, then great. If not, then we will possibly need to take a look more deeply into this MapReduce and see what we actually want to achieve and make it work. But really a nice catch, and because you are using this heavily, we actually see the problems with the indexes, which is something that we did not. I mean, we probably missed that, right? So yeah, this is regarding the indexes. Regarding the segmentation faults, I'm not really aware on the versioning in the downstreams. Obviously, in the upstream, we are much more freely on the Mongo, but in the downstream, as you may know, we are moving towards Postgres right now. So
yeah, we really like to change to Postgres too. But as far as I got you, you want to support both MongoDB and Postgres.
On upstream. On downstream, we want to support Postgres because we are moving out from MongoDB. But on upstream, we do want to support both of them. Am I right, Nimrod? Fix me on that if I'm wrong.
No, you're correct.
Yes. Okay. So yeah, that's the case. Obviously, in downstream, we will have. This is probably not relevant to downstream because we are rewriting all of that, right? And the performance is changing. But for the upstream, we definitely want to handle this and to make it work good, right? So in regards to the upgrade of the version on upstream, it is something that is doable, but on downstream, this is something that is probably not relevant because we are moving away from Mongo. Yeah, so this is in regards to the segmentation fault. So after the current meeting, I will sync up with you, Patrick and Quentin. I will give you out the commands to run on Mongo, and we will try to see if this helps. Any more additions to this issue? Anything more that you want to discuss about this issue?
Oh, no. So if you send me the comments, I will test it out tomorrow, and we'll do a quick test, and probably we'll run a more hardcore test overnight. So the last test we ran were about 1 million events, and everything was running perfectly fine. No restarts of any pods, nothing. So we're currently very happy with the stability of NooBaa with the commented out section of the creation of the functions.
Yeah.
Yeah, as you can see, I'm truly amazed that we've missed this index, and this probably should help us a lot. All right, so this is it. I also want to add, since we are here and Yanis is here as well. Do you want to maybe add to the agenda the thing that we worked on with you regarding the demo that you did?
Yeah, sure. I can present now if you want. I have the same material. Unless you have some core NooBaa discussions, I can show a quick demo what we did.
Obviously, we have lots of things that we are doing on NooBaa, but I think this is more of a community meeting. So the whole point is to engage with the community and to show up what we do. So I will let you present.
Okay.
So, you can do a quick demo and
yes.
Yeah.
Yes. So basically, okay. Okay. Let's see. Present our screen. Okay. Can you see my screen?
Yes, I can see your screen.
Okay, so this is the work that we worked together with you, Guy and Nimrod, for integration with DLF. So DLF is the dataset lifecycle framework. This is it's an open source project. I have the links here, but I can post it later. So basically, our marketing is transparently enabling and accelerating data access for Kubernetes and OpenShift workloads. So what we want to do with this work was to provide, let's say, a meta framework of CSI plugins about that connect to remote S3 and NFS data sources for starters, but we're expanding to more. So this is the very, very high level functionality. We have introduced just one new CRD that we call it dataset, that it's basically a pointer to remote data source. Now we have we're bundling also the CSI plugins that we maintain for S3 and NFS. H3 is just a new format that some of our partners are working on, but everything will be open sourced. So basically the flow is that the user is defining a dataset with S3 endpoint, credentials, so on and so forth. And then it's the dataset operator, which is the main, the core component of the framework. Invokes the necessary CSI plugins and gives back PVC, right? So the work that will focus now and what we have worked in the last weeks or so is the caching functionality that we had, that it's basically, we don't do caching ourselves. It's just that we bring the caching architecture to DLF. And what we have built is like an S3 cache plugin that is based on NooBaa. So what's happening in the case in this dataset that it's to cache, let's say, is that the dataset operator would delegate, would pass the information to the other operator, that it's the S3 cache plugin. This operator would interface with NooBaa. Currently, we're interfacing with RPC, but once the CRDs are there, we will include that. It provisions the cache. When it's ready, it goes back to the main, to the core framework, and provides an S3 mount point for the end user. But in this case, it would be cached. It would be the cached version of it, right? So this is an example of what the dataset looks like. So it's type COS, access key, secret access key, and that's how I got. I made the comment about the IAM, because we have been asked to replace that, not to replace that, but to also support IAM for IBM Cloud, the endpoint, and the bucket and the region, right? We have added also some read-only functionality as well. And this is all the backends we have tested that against. It's the IBM Cloud Object Store, AWS, NooBaa, Ceph with Rados Gateway, Min.io. We have tested it and it works out of the box. Also, there is, we have this, we added this convention of, we've given also the users the capability to use labels to mount the dataset. So basically, if someone labels a pod like this, like dataset.any-number ID, the dataset that you created, and use as mount, because you can use it as a config map. So if you want just to access the credential, the endpoint and the connection details, you can use it as config map. And then our admission controller basically just mounts the corresponding PVC. So yeah, the benefits that we see in this work is mainly focused on data engineers and scientists that they just want to develop experiments, but they don't want to be bothered with tuning, configuring data access. The storage providers can increase adoption since the framework can be extensible without changing the way users interact with it. And also, we see a value on data-oriented frameworks, like on the case with NooBaa, that we can support caching with transparently, completely. And it's also, since this is a declarative way to access and manage data sources, and we will enhance information about the dataset, about maybe the placement or where is it cached. This could be leveraged from components on top, like scheduling, right? So imagine knowing where your data is cached. Maybe the pods using datasets could be suggested to go to the pods, to the nodes that contain the cached data. Yes, and basically, I think it's better to just show you a quick demo of how this works. Okay, so I have like my directory with samples, right? And what I will do, I haven't installed. Let's see what it's running on our cluster. Okay, so NooBaa is running, and on DLF, it's just the plugins and the dataset operator, right? So let's create a dataset out of hosted on the IBM Cloud Object Store, right? So I create a dataset. Okay. Let's see what's happening. Okay. Also, something that I forgot to mention is let me see if I explain the flow here. Okay. Yeah. So basically, this is how the what we call transparent caching is working. Besides the data sets, right, we have another structure, yes, that it's called dataset internal. So basically, the dataset internal is a shadow object to the primary user-facing dataset. That it's basically for the components to look up, update, and use, right? So when there is no caching plugin available, the dataset and the dataset internal values would be identical, right? So you have your bucket on IBM Cloud, and then the dataset internal is still on the IBM Cloud with the same credentials in the bucket. So the core framework is responsible for creating those native Kubernetes components, right? The CSI, the PVC is created out of the CSI S3 or NFS, right? On the case where there is a caching plugin available, and in this case it's the NooBaa one, is it's this component that its only responsibility of the caching plugin is to only generate a dataset internal definition. So the good thing with this approach is that you can bring caching functionality from other storage solutions. Like we experimented with Ceph, we're experimenting with Spectrum Scale, GPFS from IBM. It's NooBaa now that we're working on. It's the only responsibility of this operator is in the end to generate a dataset internal definition, which is again one of the formats that we can support, S3 and NFS or host path or something else, right? So basically we say, we give you this dataset definition, you provision the cache, or you bring up any resource that you need are necessary for this to be cached. And when it's ready, just give us back a dataset internal. And what happens is that the dataset internal controller, which is part of the core framework, would again continue the same flow and provide the PVCs out of the CSI. But in this case, it would contain the cached version of this and not the remote ones. So what I want to show is that now on the datasets, we will have, as a result, dataset internal, which dataset internal would have the same exact information with the dataset because it's one-to-one mapped, and the PVC that we get is, there you go, the dataset. So which was created just 3 minutes ago when I created the dataset. So a pod can use it as simple as that. So they just need to specify the ID of the dataset and how they want to use it. So we go and create this simple pod. Okay, let's wait a bit for it to be ready. Let's give it a second. Running, okay. So as a convention, we're mounting the dataset into MNT datasets. Sorry, I forgot to do one thing that I need to do. We need to label. So basically, in order to have this functionality, you need to label the namespace. So get namespaces. So labels. Yeah, so we need to add this label into the NooBaa. Label namespace NooBaa with this. Okay, now if we create again the Nginx, okay, MNT dataset. So basically, as a convention, we mount it on MNT datasets. And if you see, it's the dataset definition, which will contain the data that there are on the bucket. So basically, what I have is just 2 files, right? And this is the data that are on the remote cloud object store. Okay, so this is the default and the core functionality of DLF without NooBaa. Now, what we did, what someone can do, right? So let's delete first of all. And the dataset. Okay, so now if we go to the plugins, right, and we have this noobaa-cast plugin, which is yet another operator, right? We just deploy that. Plugins, NooBaa, make deployment. Okay, let's wait for it to get ready. So this is just a, one extra pod running and taking care of the caching, right? Orchestrating and interacting with NooBaa. So let's go again now and create the dataset. Okay. Now, if we see a dataset internal, if we see the information now, you see that the endpoint is not anymore the remote endpoint of the IBM cloud. It's on the service of NooBaa, right? And the bucket is Kubeflow Yanis cast, and the access key and the secret access key for NooBaa. And if we go to our NooBaa admin console, and if we check on the namespace buckets, there you go. So this is created out of this orchestration, right? So basically, if we go now to the, let's create again a pod out of it. And if we go and exec, so that dataset. Again, it's the same content since NooBaa is doing that. And now, as an experiment, I want to copy it to see. So on the first run, it would be slow because it's downloading it for the first time. And yeah, so basically, the advantage that we have with this approach that NooBaa is caching it for us is that if the pod dies and the dataset or the PVC remains there, another pod that reuses the same PVC or the same dataset, right, will take advantage and fetch this file from the local NooBaa cache and not from the remote cloud object store. Now, okay, it will take a bit to download it. You can see it's downloading that. Okay, so 48 seconds, right? So let's go and delete the pod. And then create again. Okay, so we had 48 seconds. Let's see now how much it will take. CD, MNT, dataset, time copy by 2.rpm. Okay. As you can see also on my network, I'm not abusing it because fetching parts, at least, of the file from NooBaa and not from the remote. So there you go, 17 seconds. So basically, what I want to show with this is that the way the user interacts with DLF, it remains the same, right? And again, they will get PVC as something that they can use natively on Kubernetes, right? So they don't have to use data sets for, they don't have to mount their pods the way I did, but instead they can choose to use them as PVC directly. And also how transparently it happened to the end user. So imagine on the normal case where I don't myself install the caching plugin, but instead there is there's the administrator that will install the caching plugin of NooBaa, and the users won't even realize that they are accessing data from the cached endpoint and not from the remote cloud object store. So this is a short demo, and this is the work that we've done the last couple of weeks. So yeah, if you have any questions or comments.
So first of all, I want to add that this is an amazing demo in my opinion. It kind of shows a lot of stuff, and it integrates between the systems. And also, this comes to show the work and the progress that we did with, from the NooBaa side with the namespace caching, which allows basically this feature to work and to perform as it performs. We are constantly adopting and patching the namespace cache to work much more efficiently, and obviously it will improve with the time. But it is a great showcase, and really thank you that you've invested the time into doing that. I've attached. I will start presenting. I've attached. Let me just present my window. All right. So I've attached the links to the agenda for the whole project of the NooBaa caching and the NooBaa cache plugin and the data lifecycle framework. So you can obviously browse it and play with it. Also, I need to mention that currently, since this is the first step, we've Yanis coded it using the RPC in order to create all of the resources. So the NooBaa cache plugin that is running, which is basically an operator, it does RPC calls in order to create the namespace buckets and etc. Right now already we have Romy that merged the namespace bucket class and the namespace stores CRDs, which allow to create YAMLs, and the noobaa-operator will create those resources by itself. So this is a good addition because the project for the NooBaa plugin, we will probably rewrite it in the future. In the upcoming version, we will rewrite it to use those CRDs instead of triggering direct RPC calls. And this will make the code to be simpler and to understand and to use, and probably much less error prone in the future.
Yeah.
So yes, I'm totally amazed and happy with this demo, and I think that, it shows really well the capabilities. Yeah.
Thanks for your comments and for your help in that in navigating the API. So basically, yeah, I think we'll, from our side, we will run there are workloads that are very interesting that would be a perfect fit for these caching capabilities, right? So yeah, we'll do the evaluation for you in the near future. So yeah, we'll come back with more discussion points, because also scheduling is an interesting challenge that we see with that. That, you know, if you have some awareness on where the data is cached, maybe you can assist a bit the scheduler of Kubernetes, say, you know, try to go to these nodes to have a better data locality. So it opens a lot of discussions, and yeah, I'm very happy that it was well received. So yeah, thanks Evgeny.
Yeah, thank you. So are there any questions regarding that? I'm sorry that I've kind of caught it in the middle. So if anyone on this discussion has any questions regarding this feature, please ask them. All right, I guess not. Okay. So in regards to NooBaa side, Nimrod, is there something that you want to update regarding the releases, versions, or something on our side?
No, I think you covered everything. I don't think there's anything else.
All right, great. So obviously we keep working on the Postgres. I mean, we've already finished the work, so we just do some patches on some gaps that we have there. I think we are coming up to the time that we've allocated, so we can discuss this in the next weekly meeting. I'm really grateful that you took the time and joined this meeting and presented. And we will resolve obviously the funcstats and the MongoDB issues. And I think that the discussion today was fruitful, and we had lots of stuff to cover. So thank you for that, and we will see you in the next meeting. Thanks.
Bye. Have a nice day.
I will stop recording.